By the end of 1941, the Pacific Ocean had become a graveyard of steel. Japan's navy swept across the waters with ruthless precision, from the Philippines to the Dutch East Indies, from Guam to Singapore. Their empire fed on oil, rubber, and tin, drawn from conquered territories through endless convoys of freighters and tankers. And against this vast logistical machine, the United States had one silent weapon: its submarines. When the smoke cleared over Pearl Harbor, only one American force was left largely intact: the submarine fleet. While battleships lay shattered and aircraft were still scarce, those long, lean vessels became America's eyes, ears, and fangs in the Pacific. In 1942 alone, U.S. submarines would sink more than 1 million tons of Japanese shipping, a campaign that slowly strangled the lifelines of the Imperial Navy. But that campaign came at a heavy cost. Submarines operated thousands of miles from friendly ports through minefields, depth charges, and aircraft patrols. Each dive could last for hours under crushing pressure, the hull groaning like a living creature. A single leak could turn the ocean into a tomb, yet for every mission, they had to return, repaired, rearmed, and sent back again. Repairing these submarines quickly was not just a matter of efficiency. It was survival. By mid-1942, Japanese counterattacks had intensified, and the U.S. Navy's forward bases, especially Pearl Harbor, were overwhelmed. Submarines arrived scarred, their propellers bent, their hulls cracked, and their pressure valves destroyed by depth-charge shockwaves. Standard naval doctrine said such repairs required dry docks, massive steel structures where ships could be lifted out of the water for safe maintenance. But the war didn't wait for procedure. There were simply too few dry docks and too many submarines in desperate need of work. Crews at Pearl Harbor's submarine base began pushing limits, welding underwater, patching hulls from beneath, and creating techniques never seen before. Each job was a risk, each dive a test of human endurance and engineering creativity. By late 1942, the Navy's diving teams had become legends among sailors. They worked under constant danger: zero visibility, high pressure, freezing temperatures, and the knowledge that one mistake could trap them under thousands of tons of steel. Many of these men were not scientists or engineers. They were mechanics, shipfitters, and tool specialists who adapted as war demanded. It was in this crucible that the impossible repair would be born, a fix that would redefine underwater engineering. At the heart of this, innovation was not a blueprint but necessity. The Pacific War had no patience for hesitation. Every hour a submarine remained idle meant convoys passed unchallenged, supplies reached enemy ports, and the tide of war turned further away from Allied favor. In those desperate months, the line between the front and the rear blurred. The battlefield extended beneath the waves into the harbors, into the minds of those who refused to accept impossible as an answer. That mindset, forged by crisis, would soon face its greatest test, when a crippled submarine limped back to base with damage so severe that even the manual said she was beyond repair. And yet, one diver disagreed. He believed there was still a way, not through protocol but through courage, skill, and an understanding of steel under stress that only a man who lived beneath the surface could know. The stage was set. The war demanded miracles, and at Pearl Harbor's Submarine Repair Division, they were about to attempt one. In early 1943, Pearl Harbor was no longer just a naval base. It had become a living organism of repair, recovery, and relentless motion. The air reeked of oil and salt. Hammers rang through the shipyards night and day, and sparks from welding torches lit the sky like artificial stars. Beneath it all, in the dark, oily waters of the harbor, divers worked silently, unseen and often unacknowledged, saving the very fleet that carried the Pacific War. The submarine base at Pearl Harbor had transformed into a miracle factory. Its mission was simple but monumental: return damaged submarines to sea as fast as humanly possible. The men there were not warriors in the traditional sense. They carried no rifles, fired no torpedoes. Their battlefield was the cold underside of the ocean, and their enemy was time. When a crippled submarine arrived, the repair team swarmed her like surgeons in a trauma ward. Hull plates were examined for cracks, propeller shafts tested for alignment, and ballast tanks inspected for leaks. But many of these vessels were far too damaged for surface repair. They needed work done underwater, in complete darkness under immense pressure, and with tools designed for shipyards, not seabeds. Diving operations began at dawn and often continued through the night. Communication was primitive. A lifeline and a series of rope tugs. 1 for okay, 2 for trouble, 3 for emergency. The divers wore heavy canvas suits and brass helmets connected by air hoses to pumps above. If those hoses kinked, if a valve jammed, or if the ship shifted unexpectedly, the diver would die instantly, crushed, drowned, or trapped below. But the war didn't allow fear to dictate pace. By the time 1943 arrived, the Navy had begun pushing divers to perform repairs previously thought impossible. The reason was simple. Submarines were desperately needed. They were the only American vessels capable of penetrating the vast distances between Hawaii, Midway, the Philippines, and Japan itself. If even one sub could be saved and returned to patrol, it meant Japanese merchant convoys would lose another ship, another artery of their empire severed. Among the engineers and divers, a quiet revolution was underway. Men like Chief Warrant Officer John Michalowski, who had helped raise the sunken USS Squalus before the war, and Diving Officer Charles Momsen, the pioneer of the famous Momsen lung, had instilled a new culture in naval diving. It was no longer about routine maintenance. It was about innovation under fire. They developed makeshift underwater welding rigs, created pressure-resistant sealing compounds, and began using steel patch plates that could be bolted directly onto hulls underwater. Each new success became doctrine. Each failure was studied, rewritten, and tried again the next morning. And then came the submarine that changed everything. She limped into Pearl Harbor, listing to one side, her stern nearly dragging the seabed. A depth charge attack had torn open part of her aft hull near the propeller shaft. The damage extended below the waterline, unreachable without dry docking. Command considered writing her off, stripping her for parts, and scrapping her crew to other boats. But one diver, a chief among the repair team, refused. He believed the break could be sealed in place underwater, using a custom-fitted steel patch welded along the curvature of the hull, a method that had never been attempted on such scale. It was a plan born of desperation and brilliance. One mistake could flood the sub entirely, rendering the effort catastrophic. But if it worked, it could revolutionize how the Navy repaired its submarines in wartime. After heated debate, Command gave reluctant approval. The mission would proceed. The diver and his small crew prepared through the night, modifying their tools, shaping the steel patch by hand, and memorizing every contour of the damaged section. They would begin at dawn. As the first rays of light touched the Pacific horizon, the diver descended, and history followed him into the depths. Down there, beneath the surface, the story would shift from procedure to miracle. The impossible was about to be tested. For every submarine that went to war, there were dozens of men who kept her alive, most of them never seen, never decorated. The divers of Pearl Harbor's Submarine Repair Division were among the most courageous yet least celebrated figures of World War II. They didn't storm beaches or fly missions over Tokyo. Their enemy was the sea itself. These men lived by rhythm and instinct. They learned to sense metal stress through vibration, to feel pressure changes through their fingertips. The work was brutal. A single underwater weld could take hours in near-freezing water. The diver's arms trembling from fatigue while his vision blurred from carbon monoxide and oil slicks. Each dive tested endurance more than strength. They worked until their lips bled from the pressure of the helmet, until their skin burned with nitrogen exposure. Yet they rarely complained, because each submarine they saved meant dozens of sailors would return from their next patrol alive. Their courage was quiet, their victories invisible. But for the Navy, these divers became a brotherhood of engineers and warriors, men who lived between the surface and the abyss. Before this era, underwater repair was a primitive science. Most navies avoided it entirely, preferring to dry dock vessels no matter the cost. Welding underwater was unpredictable. Steel warped, welds cracked, and electrical currents flickered dangerously through the water. Tools corroded within days. The U.S. Navy's divers began changing that through necessity. At Pearl Harbor, makeshift innovation became routine. Mechanics adapted aircraft generators into underwater power sources. They experimented with special wet weld electrodes that burned hotter than ordinary rods, capable of melting through the chill of seawater and adhering molten metal to a flooded hull. Communication between surface crews and divers evolved into an art form. Each motion was deliberate, each tool handled with precision. There was no room for mistakes. One dropped wrench could damage the hull or injure the diver. In this crucible, technology advanced at lightning speed. The very techniques that would later define deep-sea welding and undersea construction were born not in research labs, but under the broken hulls of submarines at Pearl Harbor. And when the diver proposed his impossible patch repair, he was not guessing. He was drawing upon months of trial, failure, and silent learning earned in the darkness. To understand what these divers faced, one must imagine the sea not as tranquil blue water, but as a crushing, shifting mass of pressure, current, and silence. Visibility rarely exceeded a few feet. The diver's lamp illuminated only a circle of swirling silt, like working in a snowstorm of mud. Each movement stirred clouds of debris. Each tool echoed eerily in the metallic void. Temperature hovered just above freezing. Even inside heavy rubber suits, the cold seeped into the bones. Air hoses stiffened, valves iced, and oxygen flow fluctuated unpredictably. The deeper the diver went, the heavier the pressure became, compressing lungs, slowing movement, and amplifying every heartbeat. But perhaps the greatest challenge wasn't physical. It was psychological. Down there, time stretched unnaturally. 5 minutes felt like 50. The diver's only lifeline was a cord that could snap, a hose that could tear. And above him, the massive submarine, damaged, unsteady, could shift with the tide and crush him without warning. Every descent required a kind of surrender, not to fear, but to focus. To work in those depths demanded absolute calm. A single mistake and a misjudged bolt, a misplaced weld, could end both the mission and the diver's life. And yet, it was in this hostile world that the impossible idea began to take shape, that a submarine could be saved without ever being lifted from the water. It was a concept born of courage, forged by the pressure of war and tested in the heart of the Pacific. The divers were ready to try. The engineers were skeptical. The command was cautious, but the submarine waited unbroken, bleeding oil into the dark, and time was running out. The next angle would reveal why this daring act mattered beyond the dive itself, how leadership, enemy pressure, and legacy intertwined to push one man's idea into naval history. Innovation in war rarely begins at the top. Yet without bold leadership, even the most brilliant ideas die untested. At Pearl Harbor's submarine repair base, officers faced a constant battle between caution and necessity. The rulebook was clear. Major hull repairs required dry docking. But the war didn't care for regulations, only results. Men like Captain Edward Swain, head of the Pearl Harbor submarine base repair section, understood this brutal truth. He had seen the backlog, submarines waiting weeks for dock space while Japanese convoys sailed freely across the Pacific. Every day of delay meant more lives lost at sea. When the diver and his small team proposed their underwater hull patch, Swain's first instinct was disbelief. The operation defied every known standard. Welding underwater was still unstable. Pressure at that depth was unpredictable, and the submarine's structural balance was compromised. If the patch failed, the sub could flood and sink right there in the harbor. But Swain also knew something else. Morale was a weapon too. If men could see the impossible achieved, if one submarine could be saved against all odds, it would ignite belief across the fleet. And so, after consulting with the Navy's Bureau of Ships and reviewing every technical diagram, Swain gave the order, "Proceed at your discretion." It was a decision that carried both authority and risk, the kind of choice that defines wartime leadership. In the calm of peacetime, no commander would have allowed it. But in war, boldness becomes survival. Every action at Pearl Harbor's submarine base ticked to the rhythm of enemy movement. By 1943, Japan's submarine hunters had adapted. New sonar systems, faster destroyers, and more precise depth charges made each American patrol deadlier than the last. Submarines returned home torn apart by shock waves, their hulls dented, their propellers cracked. One more reason this repair mattered. The fleet was shrinking faster than it could be replaced. The U.S. industrial machine was vast, but submarines took months to build. The war at sea, however, moved by days. Every delay in repair meant another empty patrol sector, another gap in the Pacific blockade. And Japanese convoys used that gap ruthlessly, slipping through under the cover of night, carrying supplies to frontline garrisons starving for oil and ammunition. For the divers and engineers at Pearl Harbor, this meant the impossible wasn't optional, it was required. Each submarine that returned to duty meant one more Japanese ship sunk, one more convoy destroyed. The Divers Act was not just an experiment in engineering. It was a battle against time, a race to keep the undersea war alive. Even as he prepared his descent, radio updates flowed through the base. New sinkings, new losses, new orders. The war was a constant hum above and below the surface, and the diver's mission fit within that rhythm, a silent contribution to a global storm. When the diver finally descended that morning, his mission was only to save one submarine. He couldn't have known he was also rewriting the Navy's future. What began as a desperate repair soon became a cornerstone of underwater engineering. The method, sealing, bracing, and welding critical damage while the vessel remained afloat, would later evolve into what the Navy called submarine battle damage repair procedures. It became standard training material by 1944 and influenced post-war designs for both submarines and underwater construction. The diver's impossible act proved a truth that military history often forgets. Innovation is born not from comfort, but from crisis. In the years that followed, naval architects designed submarines with modular panels, easier underwater access points, and reinforced structures, all inspired by the lessons learned in those improvised repairs. Even civilian industries benefited. The techniques pioneered in wartime diving would later shape underwater oil pipeline work, bridge foundation repairs, and deep-sea construction. What began as one diver's courage became a foundation for entire industries that operate beneath the surface today. And yet, the diver himself, like many heroes of maintenance and mechanics, would never stand on a parade ground or receive medals in a public ceremony. His story lived mostly in engineering journals, maintenance logs, and the quiet respect of those who followed in his footsteps, because in the end, the legacy of that impossible repair was not about fame. It was about proving that ingenuity and courage can coexist in silence, that victory in war is as much built in the shadows as it is won on the front lines. The leadership had allowed it. The pressure of war demanded it, and the diver had made it possible. Now, as he prepared to descend for the final attempt, the fate of one submarine and in a chapter of naval history hung in the balance. Pearl Harbor, 0600 hours. The sun rose red over the dockyards, its reflection breaking across oil-streaked water. The damaged submarine rested motionless at berth, her hull scarred, her stern still partially submerged. From the pier, hoses, cables, and steel lines hung like veins leading into a wounded body. On deck, officers and engineers gathered silently as the diver prepared. His gear was primitive by modern standards: a heavy brass helmet, thick rubberized canvas suit, a belt weighted with 40 pounds of lead. Every piece of it was tested twice, because once he descended, there would be no second chances. Below, a section of the submarine's hull, near the propeller shaft, had been ripped open by a depth charge. The hole spanned nearly 3 feet across, an ugly wound through which seawater still seeped. Normally, that kind of damage meant months in dry dock, but today it would be sealed in place, underwater, against all precedent. The diver stood ready, flanked by 2 assistants checking his airline and communication rope. The patch plate, a curved sheet of steel weighing over 200 pounds, was suspended by a chain hoist above the water, gleaming faintly with weld primer. Around it, the welders and surface crew waited, every eye fixed on the man about to vanish beneath the waves. "Air pressure steady," called the surface operator. "Line clear." The diver nodded once, a slow, deliberate motion, and stepped off the platform. The sea closed over him. Immediately, the world changed. The light vanished within seconds, replaced by a murky green gloom. The sound of the surface died away, replaced by the low hum of his own breathing. Rhythmic, mechanical, the heartbeat of his existence. Each exhale formed bubbles that shimmered upward like fragments of glass. He descended along the submarine's hull, feeling for damage with gloved hands. His world was now touch, not sight. The steel was cold and slick with oil. When his hand reached the edge of the rupture, he paused. He could feel the torn metal, edges bent inward by the blast. It was worse than expected. The pressure differential made the hull tremble faintly with each passing current. He signaled the surface team. One pull, position located. The massive steel patch was slowly lowered into the water beside him, swaying gently on its hoist. It looked impossibly large down here, a shadow moving through shadows. Using guide ropes, the diver maneuvered it toward the rupture, aligning the curvature with the hull by instinct and memory alone. Every inch required precision. A misalignment of even half an inch could make the seal fail under pressure. Above, the repair team monitored his progress through the tension on the lines. Below, the diver worked methodically, bolting the lower hinge brackets first, then locking the top in place. It was slow, grueling work. Each bolt turn took immense effort, and the cold made his hands stiff inside the gloves. The silt kicked up by his movements clouded the entire area, reducing visibility to zero. He worked blind. Hours passed. The diver refused to surface. Each time the crew signaled for a break, he tugged back once, a negative, and kept working. His breathing slowed to conserve air. The sound of his own pulse drummed through the helmet. When the final bolts were secured, the diver prepared the welding torch. It was an experimental rig, designed to function underwater with a high-amperage insulated electrode. The light flared violently, turning the darkness into a ghostly blue haze. Molten metal sizzled as it met the cold water, creating clouds of steam that enveloped him completely. For minutes at a time, the diver disappeared from view. The only sign he was still alive were the air bubbles that continued to rise. Above the surface, officers stood in tense silence. If the weld cracked, the hull could rupture completely. If the oxygen line caught in the patch frame, the diver could be trapped beneath the submarine, crushed by its own weight. Then, finally, a single tug on the rope, job complete. The diver began his slow ascent. When his helmet broke the surface, he said nothing. He simply lifted one arm, the signal that the seal was holding. Below him, the patched hull glimmered faintly beneath the water, a mosaic of new steel over old scars. The sub's pumps began to test the repair, forcing out water, checking for leaks. Not a single drop returned. The impossible had been done. The crew erupted in cheers that rippled through the docks, mechanics, divers, and officers alike. For the first time, a major submarine hull breach had been repaired completely underwater. But this was only the first test. The real proof would come when the submarine left the harbor and unfaced the Pacific once more. For 3 days, the submarine remained at berth while engineers monitored the patch. Pumps ran around the clock, internal pressures adjusted by fractions of an inch to detect any weakness. The welds held, not a single rivet loosened. The diver's work was examined by every ranking engineer at Pearl Harbor, men who had once dismissed underwater welding as unreliable, even reckless. Now they gathered in disbelief. The patch wasn't just holding. It was flawless. The damage report, once a list of impossibilities, had become a testament to endurance and precision. Still, skepticism remained. Repairing a submarine underwater was one thing. Taking it back to sea, into depth-charge territory, was another. On the morning of January 11, 1943, the order was given. The submarine, newly sealed and refitted, would conduct a full-power test dive beyond the harbor limits. A destroyer escort would stand by in case of failure. The diver who had led the repair stood on the dock, silent, watching the vessel that had nearly been declared dead glide back toward open water. The crew inside felt every vibration as they descended. 50 feet, 75, 100. The hull creaked as pressure mounted, the steel moaning faintly, a haunting sound familiar to every submariner. The engineers monitored gauges with white-knuckled tension. The area around the patch was marked in red chalk, the spot everyone feared might give way. At 150 feet, the depth gauge needle steadied. The captain gave the order to hold depth and maintain pressure. Minutes passed, no leaks, no stress fractures. The silence in the control room was total, broken only by the sound of air circulation and the quiet hum of machinery. Then came the voice of the engineering officer, soft but steady. Seals holding. Pressure equalized. A wave of relief swept through the crew. They had witnessed the impossible. A submarine that should have been in dry dock was now fully operational, her hull watertight and ready for combat. The captain turned toward the engine room. All ahead 1/3, the engines rumbled to life. The submarine began its slow, graceful movement through the depths, as though testing its reborn body. The steel groaned but held, the patch unbroken. Then the captain gave the next order. All ahead full, the engines roared. The vessel surged forward, cutting through the Pacific. The stress on the hull increased, vibrations running along the repaired section. Above the patch, engineers pressed their ears to the walls, listening for any sign of strain. Still, nothing. Only the deep, reassuring hum of machinery doing its job. After an hour of trial runs, the captain surfaced. The test had succeeded. The impossible had been proven not only safe but practical. The diver's method worked, and it could now be replicated across the fleet. As the submarine returned to harbor, the diver met her at the pier. The captain, a hardened officer with decades of sea time, removed his cap and extended his hand. "Never thought I'd see a miracle underwater," he said quietly. The diver only nodded. His hands were raw, his body exhausted, but his eyes carried the calm of a man who had faced both sea and fear, and won. The report that followed changed everything. Within weeks, the Navy issued new directives authorizing emergency underwater hull repairs under combat conditions. The submarine base at Pearl Harbor became the model for rapid response maintenance. Other bases, in Fremantle, Midway, and Brisbane, soon adopted the same techniques. The diver's name was circulated quietly through technical memos and engineering bulletins. He received commendations, though few outside the diving corps ever knew what he had done. For him, it was never about recognition. It was about proving that the sea, though merciless, could still be challenged. That human ingenuity could carve a path through the darkness, one bolt at a time. In the months that followed, submarines repaired with this new method returned to combat faster than ever before. They struck convoys near the Philippines. They cut off supply routes to Rabaul. They helped starve the Japanese war machine into collapse. Each victory traced a quiet line back to that single moment, when one diver, suspended in darkness, refused to accept defeat. The war would continue for 2 more brutal years. But from that day onward, every submarine that sailed from Pearl Harbor carried within its hull a piece of that courage, welded in steel, sealed by resolve. What happened beneath the waves that winter morning was no longer just a repair. It was proof that the impossible could be engineered. In war, true revolutions rarely begin in conference rooms or command posts. They begin in silence, in the hands of a man willing to risk everything beneath the surface. When reports of the successful underwater repair reached Washington, few could believe it. The Bureau of Ships, known for its rigid bureaucracy, demanded detailed verification. Measurements, photographs, and eyewitness statements poured in from Pearl Harbor. Every test, every inspection confirmed the same thing. The underwater welds had not only held, they had performed better than some surface repairs. That revelation changed naval logistics overnight. Until then, submarine maintenance had been a strategic bottleneck. Each vessel required weeks in dry dock, time the Pacific Fleet could not afford as Japanese convoys tightened their hold over Asia. Now, thanks to one diver's improvisation, those weeks could be reduced to days. Submarines could be patched, tested, and redeployed almost immediately. The ripple effect across the Pacific was profound. By mid-1943, U.S. submarines were sinking Japanese tonnage at record rates. They destroyed merchant ships carrying vital oil and food supplies to the home islands. They disrupted troop movements, forced the Imperial Navy to divert escort ships, and strangled Japan's war economy. Historians often credit admirals and strategists for turning the tide of the Pacific War, men like Chester Nimitz, Ernest King, or Charles Lockwood. But buried within the official reports is a quieter truth, that a handful of repair divers working unseen and uncelebrated kept those submarines alive long enough to fight. The Navy recognized this, though quietly. A special commendation was issued to the submarine base at Pearl Harbor for exceptional technical initiative and courage under hazardous conditions. The diver's name was mentioned only once, buried deep within the technical appendix of the report, a footnote in the machinery of war. But among the diving crews, his legend spread like a current. They called him the man who welded the sea he had not invented. Underwater welding, the technique existed in theory since the 1930s, but he had perfected it under conditions no manual had ever envisioned: blind, cold, and under fire. His success forced the Navy to rewrite entire sections of its repair doctrine. By 1944, diving schools across the U.S. began teaching the Pearl Harbor method, named after the very place where necessity had forged invention. The war pushed these techniques even further. New electrode coatings were developed to prevent current disruption underwater. Portable power systems were redesigned to withstand saltwater corrosion. Engineers began experimenting with flexible repair plates that could conform to the curvature of submarine hulls, innovations that would later evolve into the foundation of modern underwater construction. Even after the war ended, the echoes continued. Oil platforms, bridge foundations, underwater pipelines, all benefited from methods born out of wartime desperation. The same principles that saved a single submarine now supported global industry. But the diver who started it all never sought fame. When the war ended, he returned quietly to civilian life, working in shipyards and consulting on commercial diving projects. He rarely spoke about his wartime experience, except to remind young divers of one truth: the sea doesn't forgive mistakes, but it rewards courage. To those who trained under him, he wasn't just a technician, he was a teacher of mindset. He taught that underwater work wasn't about strength but patience, that the difference between life and death lay in a diver's ability to remain calm when visibility vanished and oxygen hissed low. And above all, he taught that innovation isn't born from comfort, it's forced out by survival. Years later, when naval historians pieced together the evolution of underwater engineering, his story resurfaced. Declassified documents revealed the full extent of his contribution, and how, without that repair, the Pacific Fleet might have suffered a crippling shortage of submarines during the crucial months of 1943. His method, refined and standardized, became part of every major Navy's playbook. The Soviet Union studied it. The British Royal Navy adopted variations of it. Even post-war Japanese engineers cited it in their reconstruction programs. A single act of courage beneath the waves had transcended nations, becoming a universal lesson in adaptation and endurance. War had taken countless lives, but it had also revealed an unyielding truth: that in humanity's darkest hours, the greatest victories are often invisible, not the ones marked by explosions or headlines, but by the quiet resolve of a man tightening a single bolt in the dark, determined to make the impossible hold. The diver's success did not come without a price. The men who worked those depths lived under unrelenting pressure, physical, mental, and emotional. They were exposed daily to dangers invisible to anyone above the surface: nitrogen narcosis, carbon monoxide poisoning, decompression sickness. Many returned from dives trembling, coughing blood, or barely conscious. A few never returned at all. The Navy rarely spoke of those losses. Their deaths were marked quietly, with brief reports that listed equipment failure or oxygen interruption. There were no parades for divers, no medals pinned on oil-stained uniforms. Their work was too technical, too unseen, too silent for public celebration. Yet among themselves they remembered. Every successful repair, every welded patch carried with it the memory of a comrade lost to the depths. They understood better than anyone that the ocean demanded a toll, that the price of innovation was often written in names few would ever read. After the war, as the Pacific quieted and new technologies emerged, many of those divers struggled to return to normal life. They had lived years within an environment where calm meant survival and panic meant death. On land, the noise of peace felt foreign. They missed the rhythm of their helmets filling with air, the voice of the tender on the line, the strange comfort of routine danger. The diver who had made history was no exception. Though he never sought attention, he carried the burden of what he had done and what he had witnessed. He once told a younger engineer that underwater repair was less about machines and more about mindset. "It's not the metal you fight," he said. "It's fear. Once you beat that, you can fix anything." Those words became the unspoken creed of post-war naval engineers. By 1946, the U.S. Navy had built entire programs around what his team had pioneered. They began training specialized diving engineers, men capable not just of welding or patching, but of understanding hydrodynamics, metallurgy, and human physiology. This fusion of man and machine created a new breed of specialist, the combat diver engineer. And it wasn't just the U.S. Britain's Royal Navy, facing the monumental task of clearing mines and repairing war-torn harbors, adopted similar systems. Even the Soviet Union developed its own underwater welding corps, inspired by American success stories that leaked through post-war publications. The diver's influence, though nameless to most, had become global. But perhaps the most lasting legacy was psychological. His story became a symbol within the Navy, a quiet reminder that heroism isn't always measured in battles won, but in systems saved. In moments where logic said impossible, yet men still acted. His impossible repair wasn't merely an engineering feat. It was a lesson in perspective. It taught that innovation begins when someone questions procedure, when someone looks at a rulebook written in ink and decides to rewrite it with courage. In the years that followed, as humanity pushed into even deeper frontiers, the ocean floor, the Arctic, even space, when that mindset endured, astronauts aboard early NASA missions studied the same problem he faced: how to repair critical systems in hostile environments where no second chances existed. In many ways, his dive foreshadowed mankind's journey from the ocean depths to the void above. The ocean had been his battlefield. Pressure, silence, darkness, and his constant enemies. And yet, through those forces, he had discovered something universal: that progress is born not from safety, but from necessity. From the moments when everything seems to fail, and someone somewhere refuses to give up. That truth carried forward long after the war ended. In every harbor rebuilt, every diver trained, and every submarine that surfaced safely from the deep, a part of his courage lived on. And so, from one man's descent into darkness came a light that would guide generations, a light of ingenuity, endurance, and faith in the human will to adapt. The world above would move on, forgetting the names and the faces, but beneath the surface, in the eternal quiet of the sea, their story remained, etched not in medals or monuments, but in steel plates that still held strong. The ocean never reveals its heroes. It swallows sound, hides scars, and buries memory beneath a silence deeper than time. But sometimes in that silence, humanity leaves its truest mark, not on monuments or medals, but in endurance. The diver who changed the course of naval repair never sought glory. He had no audience, no grand stage. His theater was the abyss, his tools were faith and steel. Yet his act, a simple decision to try what others called impossible, rippled through history more powerfully than most battles ever did. In that moment beneath the waves, he proved a truth that transcends war, that courage is not loud and progress is not born from comfort. They come instead from the stillness between heartbeats, from the refusal to yield when every instinct says to stop. Every submarine that surfaced safely after that carried a trace of his legacy. Every diver who worked in darkness inherited his defiance. And every engineer who dared to push boundaries, whether beneath the sea or beyond the stars, walked in his shadow. Time has erased his name from most records, but history remembers his impact. He turned fear into invention. He turned pressure into progress. He reminded the world that technology, at its core, is only as brave as the men who wield it. And so, the story of one diver's impossible move is not just about a patch on a submarine. It is about the human will to endure, to create, to repair not only metal but hope itself. Because in war, as in life, survival is not granted by power alone. It is earned, one breath, one weld, one act of courage at a time, beneath the surface of the sea.